Let's talk about the cheapest flight within K-stop. So there are n-city connected by some number of flights. You are given an array of flights per flight size equal to from to price. Indicate that there's a flight from city from to city to with cost price. And you have to return the cheapest price from source to destination, right? So this is the n-city and there's a flight. There are flights. And this is source, this is destination, this is the number of stops, right? So in this case, we have to build a graph first. So the graph is actually the hardest one you have to build. Like it doesn't matter what you build. Like for me, I use my hash map to build it. So it looks like it's one-way direction. So which means it's only from 0 to 1, not from 1 to 0, right? So this is easy to just use hash map, and then I'm going to store integer, and then still the value is still integer, but this is not allowed because what happened is the other way, right? So you need to have an array, so I'm going to say graph, and I can actually initialize to a new hash map, and in this case this is wrong because I need to give a size, so size is n, right? I also need to declare every single array to new hash map, right? So for int I equals 0, I less than n and I plus plus. So graph at I is equal to new hash map. So this is actually the completion of initialization, and I need to I need to append. I need to add every flight into my my graph. So for int flights. So the first one flights. So I need to call from my city. So city is actually flight 0, and then I need to put. And I have another integer max, right? So put flight 1 comma flight 2. So from city A to city B with the cost of flight, right? This will be pretty much the solution for the building the graph, right? You can actually write out in a function and then we call the function, but I'm not going to do like this. So what you can do for the rest, you have to know like the minimum stop for each city and also the minimum cost for each city, right? So I'm going to say int minimum stops for each city, which is n, and minimum cost for each city, and I need to initialize everything to the really big number, arbitrary number. So for I can actually just say array.fill min stop and then integer.max value, and also my min cost to arbitrary number, which is max integer.max value. But whatever you start from the source, right, is always 0. It's always 0, right? This is because you don't need a cost from the source, right? So and also stop, right? So min stop at source is equal to 0, and also min cost at source is also equal to 0. Now let's talk about how you actually need to do. So we probably we need to use the we need to start from the source, right? We need to start from the source, and we have to traverse based on the graph, to be honest. So this is pretty much like breadth search, right? So I need a queue. So whatever comes first, I need to traverse. So queue, I need to pass in the array. So the in array is actually this is actually the destination, the location, and this is and also the cost and also the stop, right? So I'm going to say PQ, be honest, using the priority queue. So you new priority queue, and then place in array, and using the Java 8 lambda expression, I'm going to sort this PQ based on the cost, right? So the cost is A1 minus B1. So the smallest goes first. So just PQ.add. Actually, it's offered. You can use add as well. So new in, and from the source, the source is cost 0 and stop 0, right? You don't need a stop for the stop, and the cost for the source destination. And we need to traverse, right? So backwards is pretty simple. It's just say PQ is not empty. Well, PQ is not empty, you can actually do it, right? So you need to pull from the PQ, right? So I'm gonna say no, and then PQ.pull, and I'm gonna say int current location. So current location, I would say log. Just location, whatever. Equal to node 0, and then cost. So current cost is equal to node 1, and also the current stop is equal to node 2. Now, if the current location is equal to the destination, we can just return, right? If the current location, I can actually just say current location. So current location is equal to the destination. I can actually just return the current cost, right? This is cost I use, right? And if the current stop is actually greater than k, we don't need to continue, right? And now let's just traverse the neighbor from the graph. So for in next, and then based on the graph at current location, and then dot tset, right? So this is the next flight, right? So I'm going to say in next cost is equal to what? Current location dot get next, okay? So this is the cost for the next flight, and then I need to compare. So I need to compare if my current cost plus the next cost is less than the minimum cost at this position, at this city, then I need to update and then also push into the PQ, right? And here we go. So I'm gonna say min cost is equal to what? Okay, I need to check the comparison, right? So if next cost plus the current cost is actually less than the min cost at this city, I need to update my min cost next equal to the next cost plus current cost, and also push into the PQ. This is because we find out this flight will be the optimal flight for the PQ, right? So PQ.offer, and then new int. So I'm going to say the destination, the location is next, right? And the cost will be next cost plus current cost, right? And the stop sign is actually plus 1, right? Because whatever you come over here is always 1 unit increment by 1. So current stop plus 1. And if not, else if this is not allowed, right? Then we just have to depending on the stop, right? So if current stop is less than the min stop at this position, right? And I can still append, right? into a PQ. So whatever yes, whatever you use the cost method or stop method, you push into the PQ, which means you are actually updating your current stop, right? So min stop at next is equal to current stop, right? Just think about the preferred search method, and after the value you can just return -1 if everything is not returning. So if the current destination, the current location equal to destination, you will return a cost. If not, you will break out a while loop and then return a -1. And okay, this is not return -1, but at some point, like you will have to return -1 if there's no such loop, right? And they just run it and see if I have any question. Alright, not so many. This is pretty hard problem that when you want to build a graph first, then you need to know like the stop sign and the cost, the minimum cost, and also the PQ. You need to know its preferred search, and this will be pretty much the solution. So let's talk about the time and space complexity. So in this question, I'm using a Dijkstra, right? So the Dijkstra is actually Dijkstra. Sorry, it's actually using a VE. V represent the age, E represent the stop. In this case, V represent the vertex, E represent the age, right? But in this case, I'm actually switching this V and E to the age and stop. And this would be the solution. And this should be pretty simple if you know this algorithm. And then if you don't know, then just Google it and then watch a YouTube, and you will get the breakfast solution for sure. And I will talk about another algorithm for this question, but in this case, I'm pretty much finished. So subscribe if you want it, and then I will see you next time. Bye.